Good evening, everyone. Welcome back to the third day of this Python workshop. Just I would like to recap what we have done. On the very first day, we went through something called time series analysis, or data which is highly dependent upon time, and with respect to time, how to deal with the data, how this data is different from others. What are its application areas, what are the fundamental terminologies that is used in time series or the components such as trend and seasonality, how to decompose it from a time series data, and how to make a trending series or a curve stationary, right? And which statistical test to be conducted, ADF test, right? And after making those, how to figure it out, the P, D, and Q components which are used for modeling ARIMA, and how to predict it. This we did on the first day. And on the second day, it was anomaly detection. We discussed what is an anomaly, right? Or outlier sometimes, or the values which are not common, how to define them, and how it varies from one domain to another. What are the ways for anomaly detection, statistical methods, visual analysis based methods, machine learning based methods. And we first visually analyze those using a technique called box and whisker plot we used, but apart from that we used a scatter plot also, right, to analyze that. And thereafter we went for credit card fraud detection, a data set around of 24 or 28 lakh data set, out of which 490 were credit card frauds. And we learned how to model SVM, support vector machine. Using support vector machine, we trained a model, and we got approximately a accuracy of 90%. Okay, and we were able to detect fraud cases by 90% accuracy. We also learned something called confusion matrix, true positive, false positive, true negative, false negative. What are these terminologies? And from these terminologies, how we interpret something called accuracy, sensitivity, recall, specificity, etc. So we learned that yesterday. So we learned about anomaly detection too, right? And today's date is for data science in BI, right? So today it would be a different kind of discussion in comparison to what we have done on the previous day. And I want this discussion to be interactive, very, very interactive. And one second. Let me give me 1 second. Yes, now I got it. What I was looking for. Okay, so are you guys still there with me?
Yeah.
Yes, Srivani, thank you. Okay, so before we start, it's me, a computer science professor, a passionate trainer for Python and machine learning, a cybersecurity researcher with around 20 years of experience. The main theme of this workshop was to do a foundation on data science, or make aware with the people what is the big thing that is going to prevail, what kind of job opportunities are there, what is the next hot cake. So it is data science, and we emphasized it by showing certain statistics, that why it is important, at what rate it is being generated, and why it is the new gold of the era, modern era. So once, so whosoever is there, who has the data, he has the supremacy. And there is one more saying these days which is quite popular. I don't know who said it. We only trust God. We only trust God, else you must have data to prove it. So the data has to be there, from which analytically you should draw the conclusions. Otherwise, there is no way to prove it or trust how things train. So this data could be historical data, generally in the stored in the data warehouses or RDBMS. So the basic whole is that data is very important. Data is very important, and few more statistics. Then what are the job and the big salaries that you are getting in data science domain? And yes, there are many people who are shifting their jobs too. In data science, itself, people are switching from one tool or one role to another, and the companies are recruiting these guys, okay, who has this kind of skills. Some of the companies who are recruiting from SkillEnable are this statistics, and you see all the major companies are here almost. SkillEnable focuses on employability courses, and one of those verticals is data science, which is very popular. Okay, and the beauty of this program is 100% live classes, so you get one-to-one interaction with the teacher, 100% placement, and the professionals who are there, they are the experts of the tool or of the domain. For example, if you go for the data science, it is not only me who, or person who will be taking all the courses, right? They have handpicked the professionals, right? And they take the classes, right? So every one is an expert for that particular skill set. Okay. And you see some more statistics from SkillEnable: 1,100 learners, 50% hike in the salary, highest package of 29 lakhs plus. Hiring partners are quite good in number, 550 plus. Right. So job opportunities, you see, we will discuss again this thing. Data analyst. Now this is one of the major topic of discussion for us. Let us see what is this job opportunities which is here and what their role is. So you see, first one is a data analyst. What is it? Data analyst extracts, analyze, and interpret data to help organizations make informed decision. So what you are going to give? You are going to give data on the basis of which the decisions can be made by the decision makers, right? So you are helping people make decisions. So you see how important your role is. So your input is very important. If you give wrong input and the decision goes wrong, then definitely you will also have to face the heat. What is a data scientist? Okay, data scientists are advanced statistical and computational methods to data scientist uses advanced statistical and computational methods to analyze and interpret large amount of data and develop models to predict the future outcomes. So they develop the models, right? They will create the models, they will check their accuracy and which models fits your data, right? It is not necessary that whatever is created or whatever there is there in the public domain that fits you as it is, right? That will never be the case. Whichever organization you join, or if you have your friends or colleagues or relatives working, you ask them, they will tell that whatever is there in the public domain, it doesn't work as it is in their company. It is getting customized. So these people are there who use the advanced knowledge, like a scientist innovates and find out new ways. So these guys do that only. Machine learning engineer, what is the role of a machine learning engineer? Machine learning engineer builds and deploy machine learning models and algorithms. So if there are algorithms or models, they will implement it, they will create it and work on improving their performance over time. Now, there could be some overlapping between these two roles, right? These guys could also come in the picture along with the machine engineers. They work together, or it could be in a smaller organizations, the roles are overlapping, or a single person does the role of both the two. All of these two. Now, business intelligence analyst. Now, this is something different, also known as BI. Right. So what is this business intelligence analyst? Business intelligence analyst uses data to help organizations make strategic decisions and optimize their operations. Now you see, How this is different from the data analyst? Data analyst extracts, analyzes, and interprets the data to help organizations make informed decisions. But this business intelligence analyst uses the data to help organizations make strategic decisions and optimize their operations. So the strategy will be designed by this business analyst. They are the domain experts, right, who have that vast experience, and they know how our existing data or the data of the competitors can be used. Now, something that is called data engineers, or data engineers is to design, build, maintain systems and infrastructure needed to collect, store, and analyze the amount of data. Now, whatever data you need for doing this data science operations or data warehouse or this analysis or analytics, now which data do you need, right? Which data do you need? That data has to be there. It has to be long dealt with. For example, you guys are the participant of this workshop, and I have created a database where the details which I'm storing are like this. Your participant's name, mobile number, email address, right? Your last degree, your interest, right? You know about any programming language? Okay, good. Now, suppose all of a sudden we feel that there is a need that we need to analyze that the participants who are there, among the participants, who is more interested? It is a male or a female? Now, I do not have the data because I have not kept it. Now, I want to see from all over the India, which state or which city has more number of participants. I do not have the data, right? So I have not anticipated that data, but today that data I need for the analysis. Okay, so such kind of problems are the big issues, right? So it is this data science, data engineer who, along with others, analysts and architects, they decide what are to be stored, but how they are to be stored, on which softwares or RDBMS tools they are to be stored, what should be the hardware and their maintenance, periodic backup, right? They are taken by the data engineer. Okay, data architect designs the overall structure of an organization system and ensure that the data is organized and easily accessible. So this is the architect who designs it, and the other guys, data engineers, they work on it. For example, if you want to build your house, so you go to the architect to get the design of your house. Okay, and rest of other mistries and other people, they try to implement and go by the design of that. All right. Okay, good evening, Chandra Narayan. Okay, this is the role of a data architect. Now, this role, data architect, this is one of the highly paid jobs. And in order to reach here, you will have to take around 5 to 10 years, or if you are really very good skilled, because architect comes with the intuition, and when you mature, you have handle some projects, right? So from this, this is the highly paid job. Very, very good. Then comes data visualizations developer. Data visualizations developers create interactive visualizations and dashboards to help users understand and interpret data. So they are visual designers, right? And this is a new era job, and this job is also very, very popular. And there is one tool called Tableau. If you see, that is very popular. If you know that tool, you will get job. You do not need any other skill sets. If you're good in Tableau, you will get a job. And recently, a known person of mine also, he was in a company working on Tableau. He is a Tableau expert, but another company hired him on a 30% more package. And during a discussion, we said that, why are you migrating? I mean, there he will have to work on Power BI, right? So they said that it is not me who applied. The company has recruited me on the basis of my Tableau skills. And definitely when they go for the Power BI, they will train me, and I can handle after initial training on Power BI also. But luckily, the data science program offered by SkillEnable covers both the tools. So you will be trained on Tableau also, and you will be trained on Power BI also, right? And both are very hot tools. If you learn any one of these tools, at least there is a job for you in the market, right? So as a visual developer, so you may start with the visual developer, and as you mature with the rest of the skills, you can further grow, right? Generally, this visual developer role is relatively easy, right? Not much of technical expertise or detail is required, which I can say, right? But in other cases, like a data scientist, just to see advanced statistical technique, computational methods. As an architect, a lot of experience is required. So relatively with a less number of experience also, this job can be obtained, data visualizers developer. Then we have big data engineer. So big data engineer works on large scale data processing systems, including distributed systems and data warehousing, right? So they are called big data engineers. And finally, the data and analytics manager. The data and analytics manager oversee data science teams. So data science teams, whichever are the teams, they oversee and ensure that the data is being used effectively to drive business outcomes. So this team actually oversees the rest of the teams, right? So these are, you see, 1, 2, 3, 4, 5, 6, 7, 8, 9 job opportunities from one field, that is data science. You won't find that much of a spread in any other domain, I believe, right? Be it computer network, be it a software developer, right? You won't find that. And this is the thing, because the rate at which data is increasing, just to see, we need people to handle them. Okay. And these skills are not old, right? Everybody is learning, developing. The early someone learns, the early they will have the advantage. So today's discussion starts on this topic. So what is data science? Collection and pre-processing, exploratory data analysis, machine learning, model evaluation, deploy and monitoring, case studies, ethics and privacy. So these are some of the things which is covered in the domain of data science and business intelligence. So how data science comes in picture with the business intelligence, I will try to give you an overview, right? But in between, if it looks to you that it is very much theoretical, so I will bring some practical aspects also. We will do small exercises, codes, right? One second, please. To make it more interactive, right? So what is data science? Can anybody tell? What is data science? Anyone? You know, in interviews, people don't ask very difficult questions. Sometimes they ask simple questions, which becomes difficult, because even simple questions are difficult to explain because lack of vocabulary, or the vocabulary which you use, if it fits or if it is interpreted the way you want. So I want somebody, if they can introduce what is data science. No one?
I would just give it a try.
Please, please.
Yeah, so it's just try and extract the meaningful insights from the data that we have.
Yes, very good. So it is, it can be said like that, but the formal definition goes like this. Data science is a multidisciplinary field that involves using scientific methods, processes, algorithms, and systems to extract insight and knowledge from structured and unstructured data. So this is a bit more, but what you said in the simple terms, it is the same story. Right. But this story covers other aspects also. So let us see again what it is. So 1 second, 1 second, please. So if you see data science, it is a multidisciplinary field. What do you mean by multidisciplinary field? Anybody?
It includes combination of other field also, like computer science, mathematics, statistics.
They see it is a part of computer science only, data science. Yes, but it includes mathematics, linear algebra, it includes statistics, right? So it includes these two primarily, but yes, is also required for this field that involves scientific methods, processes, and algorithms and systems to extract insights, right? Now, now, data science involves wide range of techniques. Now you see what techniques? Statistics techniques, machine learning techniques, data mining techniques, and predictive modeling techniques. So we are going to discuss this. What are these techniques? But the only goal, the primary goal of this data science program, as Srivani said, that it is to use data to gain insights, right? What is there in the data that you have to get information from it. And for that, the data has to be in a proper shape so that you can apply operations. Okay. And it is a very popular saying in data science that the more you torture to the data, the more information it tells you. Like if you have a witness and you interrogate the witness or the criminal, the more you interrogate, the more information you are going to get, right? Similarly, from the data, uh, if you torture it, I mean, you apply more operations and proper operations, you will get more information from it. Now, this involves identifying patterns or trends in the data, detecting anomalies, outliers, developing predictive models, and performing other type of analysis. So through these things, we generally gain information. Now, something called data science and business intelligence, where they are and how they are related. So you see there is an overlapping thing for business intelligence also, to gain an idea about how you should drive your business, right? Inform the decisions. Earlier, there was a system that we used to call DSS, decision support system, right? On the basis of which businesses used to run. And that was a simple database from which you used to take historical data and manually analyze it and try to do it. Okay. But these days with the data science, if you see what is the difference between the two, data science focuses on future. It is explorative, explore. Automation is low. We need a planning, and something called hypothesis tests are generally included. But if you see business intelligence, they focus on historic data. So in order to see what would be my future requirement of the business, or how my business needs to grow, or if I need to give a discount, should I drive a mega sale, or what should be my stock balance. So all these things can be answered on the basis of historic data, your previous data. Okay. And the approach here is descriptive, try to describe something, right? Automation is highly automated. Business drivers are decision support. So they support decision making. And the business value is to identify the trend. What is the trend and where this trend is leading to us. But yes, in BI also, the data warehouse has to be there, the data storage has to be there, the analytics has to be there, visualization has to be there, KPIs have to be there. KPIs means key performance indexes, right? They have to be there. The visual dashboards needs to be there, right? So they all are based upon the data science. Data science, so the way data is stored. And another thing that generally comes in the mind, what is the difference between data analytics and data science? Right, these are certain fundamental things. So you say, what is data science? Ask questions. Data science ask questions, write algorithms, build statistical models, do coding, right? And how to achieve it? Using techniques of machine learning, software development. Some of the tools that or languages that may use is big data, Hadoop, Java, data mining, data analysis, Python, or object-oriented programming, through which it can be achieved. Okay. And if you see how it is done, designing data modeling processes, creating algorithms, predictive models are part of this data science. But what is the purpose of analytics? Use data to draw meaningful insights. So something which is not directly visible from it, right? Something which is not directly visible from the data, meaningful insights, the hidden meaning, right? So that is brought out using analytics, right? Here we use the concepts of data mining, okay, and data modeling, and the language we use is R. R is also a popular language for data scientists. Then SAS, SQL, statistical analysis we use, database management and reporting is a part of it, data analysis is a part of it. And at the bottom, the infrastructure on which we build it is designing and maintaining databases, data systems and databases, interpret the data sets, communicate trends, patterns, and predictions, right? So you see, basically, data science asks, explores, and builds models, where data analytics brings out meaningful insights. So it digs out the meaningful insights, right? How we should proceed. So this is the basic difference. Another difference these days, if you see analytics, there are three parts of analytics or three categories of analytics. One is called descriptive analytics, then predictive analytics, and prescriptive analytics. Anyone who knows the difference between the three? Descriptive, predictive, and prescriptive. Of course, the screen is in front of you, but anyone who knows the difference? What this analytics is. So you see, descriptive analytics describes, right? Why it happened. It tells you the reason, right? And the tools which they use is data aggregation and mining. Limitations, they work on the historical data, that why it happened and why it is happening, right? Predictive analytics, it uses statistical models and it tells you the predictions, guess at the future. What should be the future? If I have sold 500 ACs this summer, then next summer, how many ACs will I sell? Right. Accordingly, I will have to place the order, or maybe after winters only, immediately I will giving order at a later price. I will store them at for 2 months, and after that, when the summer arrives, I will sell at a higher price. Right. So such kind of predictions, predictive analytics. Right. Prescriptive analytics is if then kind of thing. If then what? Right. So for example, if you're going on a journey, and as a doctor, you are making your first aid box, right? And as a doctor, I tell you that, okay, this is the medicine. If you vomit, you take this medicine. If you get fever, you take this medicine. If you have a headache, you take this medicine, right? So if what, then that is predictive analytics, right? What is to be done if this occurs? So these are the three broad categories of analytics that is in use these days, right? Now, as data is the core part, so the data again itself is categorized into three categories: structured, semi-structured, and unstructured data. Who can differentiate between the three? Structured, semi-structured, and unstructured data. Can anybody tell the difference? Anyone? What is the difference between structured, semi-structured, or unstructured data? No one? Arnab?
Structured data means coming from a proper, say for examples, what you call column attribute, like what are the columns available regarding the data, complete information. It is in a proper form. Unstructured means it is like some missing values or something like that.
Okay. No, just I'm trying to understand what you understand. Of course, I will explain. No issues, Sanbugna, but you gave a try. Anybody else? Arnab, Vivek?
Hello. Yeah, structured data means like it will be there in an order. Unstructured data it is not in an order. We need to collect the data and need to prepare that in an order.
Okay. Thank you, Naveen. Anybody else? Mohit, Soumya.
Hello. Sir,
Yes.
structure data will be organized, sir.
Yes, but how? What do you say organized? How you say?
Like alphabet wise in the ascending orders.
No, 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 no. You are there, but
Like in
okay.
the spreadsheets and all Excel sheets.
Yes, yes. Shudhakar, Pooja, would you like to try? Arun Maurya.
Like unstructured data will not have any particular manner.
Okay, yes, that is true. Okay, let me see. You see here, the structured data, this one. Uh-oh. This is the structured data, spreadsheet containing sales data, organized by date, product, and sales region. So it is a tabular data basically. Here on the spreadsheet, you get the tables and data is here. So if it here it is date, so we get only date. If here it is the sale, then here we get only sales or tabular data. So the data which is there stored in your databases, right? You have columns defined in your databases, which we fetch using SQL. So all these are structured data, right? Excel sheets or RDBMS or DBMS data, they are structured. Unstructured data is something on social media such as Twitter, Facebook, the comments which you put, right? When the comments which you put, it doesn't have specific pattern or what you write, right? We do not write in any pattern. Everybody has a different style and you put it. But yes, this data can also be used. For example, suppose I am a big star and I am releasing trailer of PS2. What is PS2? Releasing tomorrow?
It was released today.
Today it is released. Oh, this is
Yes.
Friday. Yes, correct. So today it is Friday. Very good. So what is this PS2? PlayStation 2?
Polyselvin 2.
Polyselvin 2. Okay. So suppose I launch its trailer and definitely people start giving comments on it. Right. So from those comments, I want to see what is the trend, what is the sentiment of the people. Is it positive or negative, or will it be a hit or a failure, or how the critics are realizing? Right. So now you see, as a fan, you start giving your comments. Now everybody is a different way to write, isn't it? And from that, deriving the information or insight is challenging, isn't it?
Yes, sir.
Right. So this is unstructured data, but this unstructured data is a data and we have to draw it. So I think last month also we did a workshop and we did a sentiment analysis, right? So maybe it is there on the YouTube page of SkillEnable, if I believe. So you can see sentiment analysis, how we did it. We did it a sentiment analysis on the Twitter data also. So if you give a string, how to fetch the data from Twitter related to that, right? That also we did it. So from unstructured data also we can draw meaningful insights. So structured is okay. You know that what details you need to be stored and the data is entered by you only or your employee only. So that is the best one. But even unstructured data can give you very important things which may not be available at your end, right? And in between these two is something called semi-structured. So you know what is XML or JSON? What is XML or JSON? Have you heard the term before?
XML stands for Extended Markup Language.
Very good. It is the full form, but what it does, is it brother or sister of HTML? Can I create my website with XML also?
Yes, sir.
Yes, Tejaswini.
Yes, sir.
No, no. XML stands for extensible markup language. Now, do you understand what is a markup language? No. Okay. Very good. If you don't understand, what is HTML?
Hypertext markup.
Hypertext markup language.
What is this markup again? What is this markup again?
Sir, machine learning, sir.
No, no. What is this markup?
Language.
Pardon?
Extensible.
No, what is this markup? When you say HTML. So ML is a markup language, right? It is a markup language. So what is this markup language?
Text encoding system.
Pardon?
Text encoding system.
Okay. Now you try to see what I'm doing right now. Just look at this and tell me what I'm doing.
Highlighting, sir.
No, did I highlight here anything? What I'm trying to do here? You see? So here I highlighted, right? Here I striked through, right? And here you see what I'm doing? So indirectly, you see, I am marking the text from here to here, you highlight in yellow color. I am marking from here to here text, you make bold. From here to here text, you make it strike through with red color, right? So these are my markers. This is the starting point, this is the ending point, and how it has to be displayed. Is it not marking?
Yes, sir.
So your HTML also does the same thing. You provide tags, and from starting point to ending tag, the text or the content is displayed as per the instruction. That is marking. How your web browser, when your HTML page is loaded into the web browser, how it is rendered, how it is displayed, right? That displaying by the web browser is done on the basis of the marking instructions or the formatting instructions that you give. More precise, it is marking. So hypertext is non-sequential. Generally, when we study, we move in sequence, right? But hypertext is non-sequential. If you click somewhere, it goes to somewhere else. You click there, again, it goes to somewhere else, non-linear way. So it is hypertext markup language. But XML is similarly markup language, right? But there the markup is different. Through XML, we can create our own tags. For example, if you want to create a tag, and suppose the name of that tag is Chandu. So you create Chandu. This is the beginning tag, and this is Chandu closing tag. In between, whatever you write, your application will understand that if there is a Chandu tag, then where I should put it, how it has to be interpreted, user-defined tags, right? It is used for storing data. It is used for interoperability. This means if you migrate data from one place to another, generally they are stored into XML, and XML tags are interpreted by one another if you know the value of those tags, how these tags are to be interpreted, right? That is why if you see earlier our doc files used to be doc in Word, but now these are called docx. Your Excel file used to be XLS, but now they are XLSX. Now these X are due to this XML. You got my point now?
Yes, sir.
Right. So you see, through XML also we can create our tags and we can store data, but that is not something which is very structured, not because the tags could be user defined, right? So we call that semi-structured. A little bit of information about the structure of the data is required, right? And similarly are the JSON files or some log files. Log files are specific to a particular application. For example, IP number this sent this protocol and sent a data on this. So if they are logs, so these are again semi-structured data. So data can generally be categorized into 3 categories: structured, semi-structured, and unstructured. All right, and all are important, but and for you also, don't feel that when you go in the real world, you will find that treatment like a 5-star hotel, right? We have to clean the dirt or shit of others. The data may not be available. If available, it would be very, very, very messy. 80% of the task is cleaning the shits, right, with the data. So data science process, what is the process? First, we formulate the problem, we collect the data, then pre-process the data, analyze the data, build a model, and then evaluate if the model which we want to build is correct or not. If we are happy with the evaluation that, okay, the model is doing correctly or behaving correctly as per our expectation, then we deploy it. Deploy it means put it in a workable conditions and it is in use. So any database science project or even the machine learning project, it works on the similar lines. So our data science project is similar to a machine learning project and very similar to BI project also. They all have this similar, almost similar, if not exactly, with some minor deviations. So what are the data science tools and technologies? The popular data science tools and technologies are Python, R, SQL, and Hadoop. So you know what is Python? Python is a very, very popular programming language. And if you see, it is one of the top short programming language. If you see the job opportunities in US, highest, or Europe, it has been highest on Python, followed by Java for year 22. So you can Google it out, top search programming language or top search job opportunities. It is Python. And as you know that artificial intelligence is growing, artificial intelligence understands only one language, that is Python. It means we use Python to communicate with the AI models or machine learning models. And there is no road these days, the digital road, where you go and you do not meet AI. So anywhere you are, any domain you are, AI is going to leave its footprints, right? And in order to use, if you want to use, if you want to talk, you want to communicate, it is Python. Whether you learn something or not, Python must be known to you. Similar to that, we have R also. R is a statistical programming language, very popular, but Python has a little bit of edge, right? And then SQL, if you have structured data, then how do you bring that data out? How do you pull it? You do that using SQL queries. What is SQL?
Structured database.
No, it is not database.
Sir, it's a query language, structured query language.
Very good, Tanveer. It is called structured query language. So there is a structure, and this structure is used to query. Query means ask questions. Ask questions to whom? To the DBMS or RDBMS. So if you have a data stored in MySQL, Oracle, DB2, MariaDB, or any other database, right? So which supports SQL, right? Not all databases support, because these days we have no SQL databases also. So through this SQL, you can fetch the relevant data from a table. For example, if you want to, if you have a student, if you have a student table, right, and where you are putting a name, a roll number, right, marks, and if you want to get all the data from this student table, we write it like this: select star from student. So when you write this and you execute, so this query goes into this student table, fetches all the records, and it will give it like this: name, role, this. Whatever data is there, the data will come to you. Similarly, you have complex queries also. Select star from student, where marks is greater than 50. So only those data where marks is greater than 50 will come up. Right. So you see, this is one of the simplest example how your queries are written to bring the data out from the tables or the databases. Right. So you see Python, R, SQL, and what is Hadoop? Big data
Sir, it's the open source software framework actually.
used for what? Used for what?
So for database purpose.
Big data and big data.
Yeah.
Right. So if your data is quite big, right, by
In a-
volume, velocity, and other parameters also, we
Yes.
use Hadoop file system, which is a distributed file system. It has advantages for quick storing and fault tolerant, right? So that we manage it. So Hadoop is also there for storage and other things. For data visualizations, as you saw, we use Tableau, Power BI. Apart from this, we do have Python also, and in Python we do have libraries like Matplotlib and Seaborn, right? And for version control, if you have multiple projects and tools, then we do have GitHub or Git and GitHub. They are there for versioning of your softwares. They are there. Now, career paths in data science, as we have already discussed the job opportunities which are there. What is a data analyst? What is a data scientist, machine learning engineer? This we have already discussed. What are the skills required? You should have all the skills. All the skills in the sense that you should know how to use Tableau. You should know how to use BI. You should know Python, at least any programming language. You should have elementary knowledge of statistics, the statistics which is used in machine learning. You should be knowing about machine learning algorithms. What are those machine learning algorithms and the categories we will see very soon, right? So those skills are required. Educations, if you are from a science background, it is good. But even if you are not from the science background, it has no issues. Most of the data scientists you see, they are from non-science background, non-engineering background, and they are doing it great. It is the passion which has to be there. If it is the willingness which you have to dare what you want to do, right? And this skill sets you learn. There is no time limit. Once you learn it, you practice it, you mature in this. And basically, if you go as a data scientist or a machine learning engineer, you have to wear that detective hat. Like when you watch a detective movie and you become so eager to know he's the killer, right? This guy could be the killer. This is his or her interest in the murder, right? Similarly, when you deal with the data, then that instinct, detective instinct has to be there to bring out those insights from the data. What should I do so that I get answer to this question from the data, right? As I will show you quickly after a few slides, we will go for that also. So, and once you go into this field is rapidly changing. It is one of the fastest changing fields, that is data science, AI, machine learning. And you know, ChatGPT has come, its version 3, 3.5, 4 has come, large language models have come, and how fast they are changing. And these changes are affecting every other field. You tell me one field where it is not affecting. So you are right at the center of the wheel of change, right? If you learn it, you know where the changes are occurring. So this is something from where you look in all the domains, all the departments where there is a data. Data doesn't have a caste. Data doesn't have any boundary. Data doesn't belong to only one department, one organization, or one subject. It could be anywhere, and it can be analyzed in many ways, right? So once you choose this, you have to be a continuous learner. Continuous learner. If you are a passionate learner, you believe in learning, keep yourself updated and update yourself with the changing need, environment, market scenario, then you will be the person who will always be in demand. And by being in demand, it means that you can quote, what is the value? I need this much. People will pay you to get their work done, right? If you learn how to do it. And believe you me, there are so much of opportunities that everybody will get a job. Everybody will get a job. There is a scarcity of professionals, right? So even if you do it, you start it slowly, you mature, and you will have a job. Challenges and opportunities which are there in the data science. So challenges is data quality issue. This is the big challenge. Lack of interpretability. How this data has to be interpreted. What is its meaning, right? So these things are challenging, and these days it is ethical considerations. So how you deal with the ethical issues. Okay. So these are the challenge. People and organizations, they are not ethical. Your privacy is at risk. They use you for their own benefit. So this because the law is the privacy law still in India, the privacy bill is still pending. It is being delayed, and as a result of which we are at a stake, right? This should not have been the case. The bill should be passed as early as possible. Right. The potential opportunities in data sciences are for cost saving, save cost. This data science saves cost. It can increase the revenue growth of an organization and innovations in the business. So you see, everybody requires this. Which business doesn't require this? Who doesn't want to save cost? Who doesn't want to grow revenue? And who doesn't want to innovate and adapt to the new standards or the new requirement of the market, right? And this all are done by riding on the horse of data science. So it is the data science through which these things are achieved, right? So the role of data science is phenomenal. Data science is going to drive everything. Okay. Now, data collections methods, how to collect data. One of the methods is surveys. So what are the ways for survey? Can anybody tell what is a survey and what are the ways to survey? Yes, Ranjit.
I'm getting
Yes.
answers from like employee or whatever.
So collecting data from
Employee or common people. Maybe.
common people, right? So if I want to survey, so if let us say that I want to get a survey on what is the future of this PS2, so I create a form and I send the form, or should I go in person to everybody? So in person, I cannot go and interact with everybody because it will take time, money, transportation, and if I reach somebody's house, he's not available, he's out of a city, right? So I should create a form. The form should have appropriate data type of questions, and the cardinality of the data has to be there. Ordinal data, cardinal data, right? Or nominal data. So these are the data types. Okay, so one data which can be in order, one data which is in categories, one is data which is nominal for names and others, right? So they are there. On the basis of we do the surveys. Survey has its own ways how to do that, or we can have experiments. We can conduct experiments and the data can be collected from there. We do have observations, monitoring of certain phenomena or processes, and the data is called observational data. Or we have transactions and we can record this transactional data. Now, another category of data that is there is called primary data and secondary data. Can anybody differentiate what is primary data and what is secondary data?
The primary data comes from the researchers directly.
Directly, the person who needs it and he has collected it. For example, I need the data and I am the person who has collected it. This is primary data. And what is secondary data? The data was collected for some other purpose, but I'm using it.
Yes, sir.
Very good, very good. And the important challenge with the data is the data quality. That is the missing values. The data should be true. Its integrity must be maintained, right? So this should be the case. Now with data and data science, I recall a very popular story, which is there in among the data scientists arena, that when India became independent, people from all parts of India I don't know whether this is true or false, but it makes sense. So let us go by the story. So when India became independent, people from all part of the country gathered at New Delhi, Delhi, and near Lal Killa, right, to celebrate the independence. And the then Prime Minister, he ordered caterer that everybody must be fed and this party has to be thrown from the government. So he called the caterers. What are your requirements? Just give me the list of items, what you need, and everybody must be fed. This celebration has to be very grand. No, the caterer was a cunning one, and he gave a list of items that he needed. And looking at the list of item, the Prime Minister somehow had an idea that this caterer is trying to cheat, and he is demanding some of the quantities which are quite in large, because I don't feel that they are needed in that number. So he called one of the persons from ISI Kolkata. What is this ISI Kolkata? Barakpur. Anyone knows ISI Kolkata? No one? Indian Statistical Institute, right? If anybody has appeared its exam is very, very tough. I feel that it is tougher than IIT also. Very less number of seats. So Indian Statistical Institute, and he called a professor from there, and he said that this is it, and being a statistician, you have to find a solution to it, so that you figure it out whether the caterer is asking the right number of things or not. Because you see, he was asking for ghee, this many tons of ghee, this many tons of sugar, and this many tons of dal, and these items are relatively costly. Okay, so the statistician asked the Prime Minister that you tell me only one item, that is salt. How much of salt he has asked. Now, salt is the cheapest item. In the kitchen, if you see, the cheapest item is salt. And nobody would like to procure this cheapest item in large quantity, right? If you enter a house and you are a thief, then you would always try to live with the costliest item, right? And the cheapest item would be no way. So the statistician estimated that what is the per day consumption of salt per person, and he divided the entire quantity demanded by the caterer, and he divided it, and he came to know that this much is the number of people who are here, and through this much of salt, food for only say 50,000 of people can be made. And the ghee, dal, and other things which he's demanding, he is demanding for 2 lakhs of people. So 50,000 are the people, and he is demanding for 2,000. So definitely all the items you give as per the requirement of a 50,000 people. So in this way, you see, when you have the data, which data is the principal component, which feature is important, right? And this is the role of a detective role of a statistician or a data scientist, which he comes up to when challenges are there. And there are many challenges. This is just one of them where you have to come up with the solutions, right? Then data pre-processing, data cleaning, data integration, data transformation, data reduction, reduce the data. Why to go with all the data? Because if you go with all the data, then the processing requires time and other things. Then you have to deal with the missing values, outliers, and inconsistencies. What is missing value? What is missing value? Can anybody tell?
A type of incomplete value.
Incomplete value. So look at it. This data. What discrepancy do you see in this data? Who can describe? Looking at this, what all discrepancies you see in this data? So you are a data scientist, assume. Now look at it, and you asked me for the data, and I'm giving this data. So what do you see?
See, for in this data, like for columns, none data is there.
Pardon?
None data is there.
Null data is there, right? And so you see in this column customer ID, all the values are here, right? So this is okay. But here, if you see street number, here data is missing, right? Here data is not available. Here data is not available. This data, it's okay. So this column is also okay. Now occupied. So this is a housing data. So is this house occupied by the owner? Yes, no, yes, no. No, what is this? Right. So this is a problem. What about this one? And here you see again there is a missing data. So this data is also not complete. So number of bedrooms, how many bedrooms are there in the house? 3, 2, not available. Okay, not available, and this is also not available. So why there is no consistency? Not available, not available, number of bedrooms not available. Okay, so this data is incomplete. Number of bathrooms, 1, but what is this 1.5? How can bathroom be 1.5? Right? Not a number, again, not a number in a different way. Just you see 3 different ways to represent not a number. Oh, it's horrible. Number of bathrooms is Delhi. How can it be? Right? Okay, now not a number, and again Delhi. What a ridiculous it is. Then area of the house, 1000. Oh, now you see, not available, and somebody enters dash dash, right? And missing value. Then color, what is the color of the house? White, red, pink, yellow. What is this, the spelling of yellow? This is a new spelling of yellow. I have never seen. Green, then white. Now this white and this white, why they're different? Is it ultra white and white? So you see again there is a spelling change. Now red, can you see this red and this red? So this is inconsistency. Green is okay. Pink is okay. Yellow again and red again. So you see all these discrepancies. Now, if you remove all this, the option is that if the data is incomplete, you delete it. The simplest answer is that if the data is incomplete, you delete it. So you see how many rows you will delete. This is gone. This is gone. This is gone. This is okay. So this is gone. This is also gone. This is missing, gone. This is gone. This is gone. This is gone. So how many rows you get?
1.
11 out of 11, you get only 2.
2.
Right. So you see, out of 11, you get 2. Come on, data is the new gold. You cannot waste gold like this. Right. So you have to fix it up. Right. Suppose you have a plastic product and if it gets broken, what do? You throw it into the dustbin. Right. But if you have a golden ornament, then if it breaks, then what do? Oh, keep it in, still keep it in the safest place. We will go to the goldsmith and get it fixed. Isn't it? So with that,
सुनार का हिंदी में तो नाम ये है अच्छा, इंग्लिशों में साला अच्छा नाम दिए इसे गोल्ड स्मिथ.
pardon, Aswini?
Hello.
Yes, I could not hear you.
No, sorry for this. Actually, someone other is doing that.
Okay. It's okay. I thought it was for us. So all of you now looking at this picture, you realize what is the challenge with the data?
Like collecting the correct data, it's a very big challenge.
Big challenge, yes, and 80% of efforts goes here. So anyways, the job of data cleaning is here. We have to clean and revive it. How can we do so? For example, in bedrooms, let us go how many bathrooms are there. So you see all the bathrooms where the data is incomplete. Okay, take a mean or average of this and you substitute the average value where there is no data. Number of bedrooms, wherever there is incomplete data, you substitute with the average or mean and you try to substitute it. So we can get rid of it. Area, take the average of all and substitute it here or mean here. There are 8 or 10 techniques, not only substituting by mean or average is the method. What about this one? How we are going to find it out? This one, this will require something else. And how we are going to check this one, that there is a 12 or not. If I give you 1 lakh data and in 2 places it is like that, then how do you do that? Its detection itself is difficult. So you will have to write Python code to check data type, right? And if it's this is an integer data type, so if it in a text column, if find an integer data type, then how that correction has to be done, right? That is the part of cleaning the data, right? This is where data cleaning comes into picture, and there are ways to do so. For example, if you want to drop missing values, so the command is drop NA. So drop NA, it deletes all the rows where there are NA, not available values. If you know street number and if you know which street number it is, fill NA, not available data, with this value. If you know particularly, you can go by index number and column number and you substitute the values. Number of bedrooms, you go with the median value. You calculate the median value for a particular column and fill it with the median value, right? This is how we clean it, right? Similarly, if you see, if there is an integer, then if the exception is thrown or not thrown, how do we do it and how we replace it? So that at least we first convert it into not a number, and then we do the modifications or replacements. So these are some of the ways how we clean this data. A detailed method is there. Just I try to give you an example, right? How to do with the missing values, how to detect the outliers. We have learned already yesterday by visually or by putting some constraints, we can reject them. If there are some other consistencies in the data, then how that has to be done, that is important. Then there is something called data wrangling. What is data wrangling? Just you see. Data wrangling means preparing the data for processing, for final processing. Now you see, data cleaning is just one step of data wrangling. So data cleaning, what we have learned, that is one part of data wrangling: discovering, structuring, cleaning, enriching, validating, and publishing it. So after publishing, it gets ready here, right? And then finally visualize it. So data wrangling is a bigger step than data cleaning. We discussed that in this program. Data explorations, how do you explore data, how the data looks like? So, okay, data visualizations, if you go for a summary, then statistically, by correlations, and the libraries you use such as Matplotlib, Seaborn, and ggplot2. These are again libraries through which you can plot data, apart from those Tableau and Power BI, right? For data science explorations, generally these libraries we use, right? So feature selection is one of, again, the things that which feature is important and which features we should use in building our model. That is important. Then something there is called data sampling. What is data sampling? Can anybody tell? What do you mean by data sampling? And why do we do data sampling?
So we divide data into two: test data or train data.
Okay.
Then we make a model to fit in after prediction.
Okay. No, you see, data sampling means picking samples from something, right? Data sampling means picking data from something, right? So if for anything, if all the data is available, right, that is called population. If every data which we want to have is available, then we call it population, right? And if from that population, if we try to pick some of the data, okay, that is called sample, right? And whenever we pick a sample from something, that, for example, suppose this is my regular class of 100 students, right? And I want to survey on all these students, right? And let us say my survey is that I want to find it out the average age of the student, average height of the students, right? So in order to get this average height of the student, every student must be present in the class, isn't it? And if every student is present in the class, all of the 100, and if I get the data, then this is called population. But it is not possible that entire data is available to us in all the cases. So population data is not available. So what we do, we choose students and we call that set as sample. And this sample should be a true representation of the population. What does it mean? Whatever the characteristics of all the population is, all the data is, that should be deducted from this sample also. Right? For example, suppose I want to see what is the average marks of the students in the class. And I pick 3 students and I pick it from the very first row. And in all first row, I see that all the studious students are there. And if you see the average of these students, the average is 95%. So should I conclude that the average marks of the class is 95%? No, because I have chosen the wrong sample, right? So how should I choose the sample? So there are very large number of sampling techniques. Okay, so random sampling, stratified sampling, oversampling, right? And there is something called cross validation. So cross validation is something which we use in machine learning. And how do we use it? Suppose we want to train a data set, right? So generally we split the data into training and testing set, 80% and 20%. But that has issues. So what we do, we divide the data into case sets, right? And we train it multiple times. So in the first round, we will keep this data for testing and others for training. In the next round, this block is kept for testing, right? And others are used for training. In the next round, again, it is repeated as per the diagrams. And the accuracy of all the rounds are calculated. And at the end, we take average of all of this. So this is a better approach. And this is known as K-fold validation. This is something which is known as K-fold validation that we use. So K-fold cross validation also we see. Machine learning, there are different techniques in machine learning. Machine learnings can be categorized as supervised machine learning, unsupervised machine learning, and reinforcement learning. So in supervised machine learning, as you know, that there are labels, the data is labeled. In unsupervised, there is no label. The learning algorithms works itself, and clustering problems are example of unsupervised machine learning techniques. Example of supervised machine learning techniques are regressions and classification. And there is something called reinforcement learning. What is reinforcement learning, if anybody can tell?
It is a feedback-based learning.
Pardon? What is it?
Feedback-based learning.
Feedback-based learning, no. Anybody else? Shrikant, Kishore Naik, Soumya Singh, Aruna Priya. Reinforcement learning, no one knows. Okay, look at the video. Look at this video very carefully and then you tell me. You hit the pink sheet, you get a reward. You hit the pink sheet, you get the reward. If you hit the pink sheet, you get the reward. Now you see, it is never hitting other color sheets. Why it is hitting pink sheets? Because if you do it, you get the reward. right? And if you get pink other sheets, you won't get any reward. You may be penalized also, right? So it quickly learns that it is the pink sheet. If I click, I get the reward. So it is the reward and penalize model. So if you do good things, you get rewards or credit scores, and slowly you learn what you have to do in order to get more and more scores. Right. This is a model on the, this is the basic principle on which reinforcement learning says. So in gaming, if you hit a person, you get a health, or in which direction the enemy should move. Reinforcement learning is of great use there. Okay, anyways, we have linear regressions. What is linear regression? Is a machine learning technique where a supervised machine learning technique where we try to predict continuous value. What is this continuous value? Continuous value means you want to suppose predict temperature, you want to predict salary, you want to predict population, right? You want to predict CO2 emission, right? So you see, if I want to predict temperature, so temperature could be, what would be tomorrow's temperature? So it could be anything between 30 to 40, 32.3 or 35.7. So this is called continuous. What could be someone's salary? So someone's salary could be maybe 70,000 or maybe 85,000, 81,000, anything between this. So these are all called continuous values. So this is part of linear regression. Logistic regressions, it could be something, though the name is regression, but it is a classification algorithm. For example, will Satya tomorrow come to office or no? Yes or no. So it would be either yes or no, right? So this is logistic regression, right? The name is regression, but this is a classification problem. Similarly, decision trees, random forest, neural networks, they are all different types of machine learning techniques. Neural networks, anybody has idea what is neural network? Neural network is derived from human brain, and in human brains, we have neurons. Similarly, on the basis of this, this model was created, something like this, where these are called the neurons. These are input values, I1 and I2. And here we may have some output values also, right? So this is a simple neural network. 1 second, please. Let me attend. Okay, so you see, this is a structure of what you call neural network. So these are called neurons, and these neurons and processing capability. We get some signal, we have weights, and we multiply. Some mathematical operations are done, and these mathematical operations finally leads us to some solution, right? So this is called neural network, or also known as artificial neural network. Right, and you see there is input layer and this output layer is there, and there in between this is called hidden layer. Right, now if this hidden layer, there is only one hidden layer. If this hidden layer increases, so we do have a more number of neurons here in between, so it becomes deep learning. It becomes deep learning. So if there is only one hidden layer, it is called a neural network, or ANN. Okay, or in simple machine learning is one type of machine learning also. But if the number of layers increases, this is called deep learning. So we will see again, what is it? So these are popular machine learning broad categories, right? Model building and evaluations. Once we build a model, then we have to, before that we have to do data splitting, model selections, hyperparameter tuning, accuracy, precision, recall, derived from the confusion matrix that we did yesterday, something called F1 score, ROC curve, AUC curve. And this is important, bias and variance trade-off and overfitting. This problem has to be dealt in every model that we create, right? So this is important. Regression analysis, I told you what is linear regression. So it's linear regression is where linear models are applied like a straight line. Multiple regressions where there are more than 2 factors used in that. And logistic regression, I told you, then something called regularizations to prevent overfitting. L1 and L2 regularization techniques are there. Then for classifications problems, we do have decision trees, a random forest, support vectors, naive Bayes, something called ensemble techniques. Any idea about ensemble techniques? Anybody? Anybody has an idea about ensemble techniques? You have seen KBC? You see, you have you seen KBC? Guys, are you there?
कौन बनेगा करोड़पति?
Yes, yes. What is audience poll over there?
Phone a friend.
Audience poll. I'm not
Oh.
talking about Lifeline. Audience poll.
अच्छा, okay sir.
So what is audience poll? What is audience poll?
Yeah, in audience poll, we'll collect the maximum number of votes from which have given from the audience.
Right. So if I give something, if in this ensemble techniques, so T. So what happens? I will have multiple models. I have multiple machine learning models, and the same problem is sent to every model. And what is the output if you see? So if out of these 4 models, maximum vote goes for the true, so my output would be true. So this is ensemble techniques, roughly. Right. So here we go for the voting, and we give this to either different kinds of machine learning models, right? And what the output they are giving. So the majority of the output what they give, we will go by that. Right. So this is ensemble technique, a very good technique that is popular in machine learning. Unsupervised classification algorithms, K-means is one of them. Clustering techniques, hierarchical clusterings. So that this you learn. Deep learning, as I told you, you see here, input layer, output layer, and in between you see there is one single layer. Right. When this layer increases, so this is called deep learning. Data visualizations. For data visualizations, you have tools like Tableau, Power BI, R, Shiny. Okay. And through this, we can create the different colors of charts and coding and all things. We can also create dashboards. What is dashboard? What is dashboard?
Displaying output in view.
So it is a control panel kind of thing. If you see your car, there is a dashboard in the car, right? Where you come to know what is the speed, what is the fuel, what are the indicator, what is the status of your battery, right? Similarly, in a business, a dashboard has all the KPIs, key performance indicators. They are there in one screen, right? And they are real time if something is increasing or decreasing, right? So dashboard can also be created. Sometimes executives want their dashboard to be there, either on their phone or on their screen, right? So these are again part of this data visualization also. Now, if it is getting bored, then let us go for this data storytelling. So from the data, you have to create a story like a hero's journey, and you have to tell it like that. For example, let us take a case study and to bring you out of your sleeping zone. Okay. Now you remember the popular movie Titanic? Popular ship Titanic, you remember? What happened with the Titanic? Soumya, can you tell what happened with the Titanic, or Kavita? Rupali? Only few are saying, others are sleeping. Is it late night?
No, sir.
Mohit, Ojas, Arun, Shreyas, Dinesh, what was Titanic? Udaydas, Shudhakar.
Titanic is a water jet. There
What
is
is,
some story.
what is Titanic?
Titanic is a ship.
Sir, it's a ship.
It was one of the biggest ships. What happened with it?
Hit by an iceberg.
Yes, it sank on its maiden voyage. On the very first journey, it sank. Right. So, and there is a movie also on that, right?
Yes.
Who are the actors of that movie?
Hollywood.
DiCaprio.
Leonardo DiCaprio and Kate Winslet. Right. So you see, we have a data set, and from this data set, let us look at the story. So this data set is available on Kaggle. The data set is like this. This data set has 891 observations, rows, and there are 12 variables or columns in this data set. Now, what it is, first column is passenger ID, 1, 2, 3 for passenger ID. Second column is survived. Who all survived that sinking event, right? So if there is a value of 0, the person could not survive. If there is a value of 1, it means the person survived. Now it's interesting. All of you, please concentrate. Passenger class. In that ship, the tickets were in 3 classes: first class, second class, and third class. Then we do have the name of the passengers like Broad, Owen, Harris, Cummins, etc. Then sex, whether the passenger was a male or a female. Then age of the passenger, right? It has NA also. Siblings, if the passengers has brother or sisters. PR, if the parents were there or not. Ticket number, fare, how much price did they pay as a fare, cabin number, and embark. Embark means which station they boarded, and this embark station is again SC. C is for Cherbourg, Q for Queenstown, and S for Southampton. So is this data set clear to you all?
Yes, sir.
Okay.
Yes, sir.
So now let me ask some questions. Visually analyze the patterns. What was the survival rate? How many passengers survived and how many died? What was the survival rate gender-wise? Means male and female. Can you tell me how many male survived, how many female survived? What was the survival rate by ticket class? Can you tell me, if we go by the ticket class, how many people survived? There were 3 classes: first class, second class, and third class. I want to see, because I doubt that during disaster, it is that everybody should be treated alike, but I doubt that those people who were there, they did a partiality, they were not impartial, and they saved first class people more. Is it like that first class people were powerful, they were having money, so they were their lives was more precious than people who were traveling in second class or third class? Is it like that? I have a question, right? And then what was the survival rate by class, ticket, and gender? And that too in a class, whether males were or females were saved equally, or the males were generally powerful. So did the males lost all their wisdom and they rushed to save their life instead of saving lives of women and children? Because the disaster rule says that the female and the kids should be saved first. So did it go by that rule, or what happened on that day, right? And age-wise, I want to see if young people were saved or old were saved, because maybe old people have more money generally. So again, the rich person were saved, or what happened? What did happen on that day, that night especially? What is the survival rate by age, segmented by gender and class? And again, I want to see by age, by gender, and by class, all things 3 together, what happened on that day, right? So let us see. So this is survival rate. So you see out of this, 0 means deaths and 1 means survived. So on that day, what happened? Did more people died or more people lived? What do you conclude from this?
More people died.
More people died. Very good, Dipanshu. Now you will not answer. Next, who survived? Now you see 0 is for survival and 1 is for survival, 0 is for dead, and pink is for female and blue is for male. So you see those who died, among the dieds, who were more, male or female?
In died, male is more.
More,
Female is,
yes,
less.
male,
And
more
in
male
survival,
died. Yes,
in
more male
survival,
died.
female is, yes.
Yes, more male died and less female died. And those who survived, who survived more, male or female?
Female.
Female survived more and male survived
Soumya,
less.
अब आप आंसर नहीं करोगे, neither Naveen. So you see, female survived more in comparison to male, right? So at least men who are generally muscularly more powerful, they didn't use their muscle power. They used their what you say, their what?
Sympathy.
Not sympathy. They're men to protect
Kindness.
ladies. Yes, kindness, and they use their wisdom to save more number of males, females. Now you see survive rate by class: first class, second class, and third class. So you see in first class, this many people died, this many survived. In second class, this many people died, this many people survived. In third class, this many people died and this many people survived. Now I have a question. If you see the survival rate is quite high in first class. So can I conclude that rich people or powerful people, they were saved more in comparison to second and third class?
Yes, sir.
Yes, sir.
Ranjit and Dipanshu, they say yes. Anybody else?
Yes, sir.
Naveen, yes. Okay, apart from you three are the only one who are answering along with Soumya Singh. Anybody else?
Yes, sir. Yes, sir.
Okay, good. Anybody else? 4 answers.
Yes, sir.
Okay, Subramaniam. So you say that rich and people were saved more in number, those who were traveling in the first class, and the third class people, they were given less preference, and second class too, right? But believe you me, this is where you have to take your detective hat on. What sometimes is revealed from the data set doesn't tell you the real picture, right? Here you need to have the domain knowledge. You have to have the knowledge about the ship, right? How the ship was built. So if you see, the first class was near the deck. सबसे ऊपर first class था. उसके बाद second class and then third class. Third class was at the bottom. And when the ship was hit, first class people reached on the deck first. So those who reached first, lifeboats started, and the more first people got boarded on the lifeboat and they got saved. Third class people reached on the top late, right? So that is why less number of third class people were saved. And so were the second class people. They were in the middle, so they reached there. So this is the reason, exactly not it is that the influential people were saved. Since they reached on the deck, every life is equally important. And this, the rescue team has to send on the lifeboat. So one by one, the lifeboat started, and those who arrived, ladies and kids, they sat on the lifeboat and they started their journey. Is it clear?
Yes, sir.
Okay, so here the context that we get from the data is wrong. Domain knowledge is important. Now, survival count class-wise. So you see, in the first class, I'm doubtful that, still doubtful that females or kids were given preference. So let us look at that angle. So in the first class, if you see, those who died, more number of men died in green, less number of female died. And those who survived, you see, more female survived. Right? This is good news. Now, you see, second class, again, those who died, more number of men died, less number of female died. And those who survived, more number of females survived. And in class 3, you see, again, More number of men died, less number of female died. More number of females were survived in this class too. So can we say that in all the three classes, women's were given priority?
Yes, sir.
Yes, sir.
Right. So women's this day fight that yes, women's are no less than men and we have equal right? But definitely in this case, men's will love not to give their right back to their ladies, and this right must be there with the men to save their ladies. And I hope they won't mind ladies, right? So here more number of females were saved. So this is evident from this visual diagram. Age-wise distribution, let us see how many, if we age-wise you see, those who died, their ages were like this in number, and their ages if you see. So if you see on the later half, those who were aged, they died. Only there is one person with the age 80 who survived. Otherwise, you see 65 plus people, they prefer to stay there rather than saving their life. And if you see in early part, good number of people, young people, they were saved around 20 to 30. Even kids and all, they were saved. So this blue graph is left skewed. So more saving data is on the left hand side. So we can say that younger people were saved, right? Now you look at the box plot, those who died, those who survived, and these are the outliers. So those who survived, there are only one person of 80 years who survived, okay, and 2 years too. And those who died, you see there are also outliers. All right, mean is approximately at the center. So here, this one is a bit lower, but okay, it's almost at the center. Now, age distribution, class-wise and sex-wise, right? First class, male and female. So you see the age of the patients. Second class, female and male, the ages who survived and who died. Third class, female and male, their ages and who survived and who died. So you see most of the cases, female survived and male, you see the more number of color in pink. All right. So more color in pink. So they could not make it. They could not make it. Right. Yes. And next, the same diagram in a different way, the survival rate and this. So this is basically a visual interpretation from the data, how I'm trying to build a story, how I'm trying to tell you a story from this data. This is an example on the Titanic data set, right? So hope you like this example and storytelling. How we are visually bringing that insight from the data, right? So now let us come back to our business applications. Data science has business applications in almost all the fields. Real world examples include recommendation system, predictive maintenance, fraud detection, data science, privacy, ethical considerations are important these days. But you see, data science is in every field, every field. Project management and collaborations. So project management and collaboration tools are also used here. Such tools are called Jira, Trello, and Asana. Best practices and methodologies are agile methodologies, which are used in data science. For versioning, we use Git and GitHub. Ethics now, yes, ethics is something which is important these days, where there is privacy a concern. So you see, ethical considerations are still there in data science. It is privacy, biasness, and fairness, whether our data is being used or not, our privacy is attacked or not, the companies are fair or not, right? They follow fairness or not. And there are certain guidelines, but still not in India. In US and Europe, you see GDPR, General Data Protection Regulations, and California Consumer Privacy Act. So you cannot share anybody's data. If you collect someone's data, it is not that you can share this data with anybody else. No, if you do it and it is detected, you will have to pay its consequences, right? Even organizations like ACM, Association of Computing Machineries, and IEEE, they too have their code of ethics. And what do they say? You see, ACM says that Its code includes specific guidelines related to data science, such as ensuring that the data is collected and used ethically. It is ACM which says respecting privacy and confidentiality and being transparent about the data collection and use. Whosoever you data collect, you have to tell them that I will not use, or if I will use it, then for what purpose, right? You cannot ask anybody to give their mobile number or email address as it happens in India. When you go to a society, you have to do the database entry, you have to put it into the log register. No, where that data goes, who can use it, who will take care of its privacy, right? Similarly, if you see IEEE, it has a project aimed at developing guidelines and standards for ethical development and deployment of autonomous and intelligent systems, and ethical principles, including ensuring that the system are designed to serve human well-being, respecting human rights, and ensuring transparency and explainability. Now, if you see these days, it is in the news that the research on AI and other systems should be postponed for 6 months. Why it is so? Why it is so? Because the government agencies are still null how to deal with the AI issues and the privacy issues. The technology has developed so fast, and ChatGPT and others are being used in such a way that they have no rules how to handle or prosecute, right? So they are saying that you first pause it so that we have rules and regulations in place, and cyber laws are, lawyers these days are busy. If you go and follow them, you will find a lot of discussion on this topic. Data management and storage, if you see relational databases, NoSQL databases are there, and data lakes are there. The other operations that are performed on the data wrangling and pre-processing, which we have discussed. Cloud computing is these days available, and the major cloud players are AWS, Azure, Google Cloud. Big data technologies, including Hadoop, Spark, and Kafka. They are quite popular because if the data size increases, then you need a big data technology for handling it. Model deployment, once you make a model, it has to be deployed. These days, the preferred deployment is on the cloud, but you can locally also deploy it. And there are technologies that help its model deployment so that it can be made reusable. Business applications of data science, any field, marketing, fraud detection, supply chain, finance, healthcare, retail, everywhere this is there. Data governance and security, this is something which is very important, privacy, security, and data governance. Collaboration with teams. So if you work on data science projects and the collaborations for, we use tools like Slack and Microsoft Teams so that you can collaborate with the teams while working on this. Career developments, if you see portfolio, networking, and the continuation. So you start with anywhere where you land in a data science domain as per your expertise. Slowly build your portfolio, increase your skill set slowly. All of the skill sets you cannot grow or hone in one go. So you start with one, do the networking with the people from the same field, right? Follow them on LinkedIn and others. What is the thing that is going on, so that you slowly have a watch on them, learn and skill, and then you continue your educations, and then you elevate yourself for the next opportunity. Emerging trends in data science, if you see, it is the AI which is going to lead it. Machine learning, deep learning, and AI, they are going to be the dominant players in data science. Now, there is a confusion with most of the people, what is data, deep learning, what is machine learning, and what is AI. So you see, everything is AI here. Out of that AI, some part is called machine learning. And out of that machine learning, also some part is called deep learning. When the layers increase, it is called deep learning. When the layer is a single hidden layer, it is one type of machine learning. There are multiple ways a machine learn. Also, we call learning methodologies. So there are many learning methodologies, right? And they all are part of AI also. So AI is that bigger umbrella where they all like machine learning and deep learning. Now, what is future of business intelligence? So you see, it's a shift towards real-time data, predictive analytics. Real-time data means, you see, if you go on the site like Myntra or Amazon and you log in next time to your Facebook, you get an ad related to the item or the product which you have added to the cart or you have seen there. So this processing is quite fast, and from one platform to the other, you get it. This is the need of the hour. They want it to be real time, right? And here machine learning techniques and natural language processing, augmented analytics. Okay, these are the terminologies: dashboards, personalized dashboards, prescriptive analytics. These are the things which are going to dominate future. This discussion on data science education. So you see these days, more and more number of courses are also coming up on data science because of the need. The need is there, the job opportunities are there, right? And for that courses in the engineering also, the certificate programs, diploma programs, and the students, all the participants or the working professionals, they also want to learn and upgrade themselves and jump into this domain. Future of business intelligence, if you see, it is to be dominated by AI. Then it is the cloud which is going to dominate BI. All the businesses are to be controlled from the cloud, because the risk of maintaining an infrastructure in the campus is very tedious and difficult. So the companies want that no pain should be on our end, including the security, installation of new resources. If the business grows, let it be handled by the cloud. So there is a growing need of the business on the cloud. Data visualization is increasing. Different types of innovative graphs are coming up. Augmented analytics is increasing. What is augmented analytics? Let us have a look. Augmented analytics is an emerging trend that combines machine learning and natural language processing to help business automate data analysis and get insights. So it is NLP which is coming up with this. Then we do have mobile BI on our mobile phones, business intelligence. You can compute with your phones, and self-service BI with increasing in demand of data-driven decisions making. Self-service BI is likely to become more popular. What is this? This allows business user to access and analyze data without the need of the technical expert. So all the features are there. You can drag and drop, you can choose the options, and you yourselves can dig out some of the patterns from it. So this is self BI, and this is it as an overview of data science and BI from where I started. Thank you, Sanchita, and thank you everyone for being so patientful and attending this session.
We are honored to have you, and thank you all candidates